Hello everyone. In the previous classes we have read about recursive functions. In that class I have told you there are different methods to solve the recurrence relations. One is substitution method, second one is tree method, third one is master theorem. Today we are going to learn about substitution method. This is the go-to method. Okay, what is go-to method? Go-to method means most of the questions in GATE we will be solving using master theorem only. But substitution method is the go-to method. If you can't solve the question by master theorem or tree method, then definitely it will be get solved by substitution method. Keep this thing in mind. If something happen, then you can go with substitution method. This is the question. There are two properties of recursive functions I have told you in the previous class. One is base condition and second one is main logic. So main logic is not that important, but the base condition is much more important. What is base condition? Here base condition is written as for n equals to 0, 1 will be get returned. If this condition is not mentioned, then for n equals to -1, then -2, -3 it will be going on. Because here it is calling t of n minus 1. Suppose n equals to 5, then it will be calling t of 4, then 3, then 2, then 1, then 0. It will be going on. It will not get stopped. So to stop this sequence, we have a condition called base condition that helps us to find out the time complexity of a recurrence relation. This is the questions we have given. So let's try to solve it. As the name suggests, substitution method is nothing but you have to substitute the values. We have to find out what is the time complexity of t of n. Order of t of n. This is our main aim. So what we can do, t of n equals to t of n minus 1 plus 1 for n greater than equals to 1. Suppose n is greater than 1. This will go on. Now I will substitute t of n minus 1. So how can I substitute t of n minus 1? If I will be replacing n with n minus 1, then what I will be getting? T of n minus 1 equals to t of n minus 2 plus 1. So I will be putting this value of n minus 1 here. How much I will be getting? T of n minus 2 plus 1. Then this before this plus 1 is there, the value t of n minus 2 plus 1 I am putting in place of t of n minus 1. Now I will be putting t of n minus 2 value here. How much it will be t of n minus 2? See here. If I will be putting n minus in place of n, then what I am getting? T of n minus 3 plus 1. Then I will be putting it here. T of n minus 3 plus 1. Then these 2 plus 1 are there before. From this sequence you can get the idea. N minus 4, then 1 plus 1 plus 1 plus 1. Till what point it will be going on? So this is the main idea you need to think about. Till what point this sequence will be going on. Till n equals to 0, it will be going on. Some stage this will be getting t of n minus k plus, see here 4 is there, that's why plus 1 plus 1 plus 1 plus 1. So I am getting 4. If k is there, then how much I will be getting here? K, right? It will be stopped when n minus k equals to 0, because when this value equals to 0, then it is returning 1. So then what is the k value? K value should be n. It will be stopped when t of 0 plus this k value becomes n. So t of 0 is 1 plus n. 1 plus n can be asymptotically written as order of n. So this is how we are finding out the time complexity of a recurrence relation using substitution method. So let's dive into another question. In that previous question, the recurrence relation is directly given, so it is easy for us to find out the time complexity of the recurrence relation. But here this is a pseudocode. Pseudocode means you must have known what is pseudocode. Pseudocode means it is not written in any of the coding language, but it is a kind of algorithm. You can, by reading it, we can get the idea what this algorithm is trying to do. From this we have to find out the recurrence relation. This is our first step. The first step is to find out what is the recurrence relation from this algorithm. This is the base case. When n equals to 1, then it is returning 1. So this is the base case. So I am writing t of n equals to 1 if n equals to 1. N is greater than 1. It is returning 3 into t of n by 3 plus 1. From here you can get it. If recursion of n is taking t of n time, then recursion of n by 2 will be taking t of n by 2. In the same example we can take one bread is eaten by someone. It will be taking 3 minutes. So half of the bread will be eaten by 1.5 minutes. In that same logic, we can write it as t of n is taking recursion of n is taking t of n time. Recursion of n by 3 will be taking t of n by 3 times. This is the recurrence relation we have got. From this, we have to find out what is the time complexity. So now it is easy for us to substitute it. So we have the relation when n is greater than equals to 1. We are getting 3 into t of n by 3 plus 1. So now what is our job? Our job is to substitute this term. So t of n by 3, how much we will be getting by replacing n by n by 3? We will be getting 3 into t of n by 3 plus 1, because if it is n, then it is n by 3. If it is n by 3, then it will be n by 3 by 3. So by solving it, we will be getting 3 into t. Then this will be 3 n by 9 plus 1. Now I'll be simply substituting this 3 into t of n by 9 plus 1. Then let's go further. I'll be substituting what is the value of t of n by 9. What will be t of n by 9? 3 into t of n by 9 by 3 plus 1. So how much I will be getting? 3 into t of n by 27 plus 1. So here I will be substituting that 3 into t of n by 27. Sorry, here one I have left. Okay, so this will be the bracket because this term I am replacing. This term is this much. So this will be inside the bracket. For this will be the bracket. Okay, because this term I am replacing. Then here plus 1 will be there. Then plus 1 will be here. Okay, so in this manner you can see the pattern. We no need to find out all these terms. You can see the pattern here. I will be opening up this bracket. How much I am getting? So this will be 3 power 3. Here t will become, then n by 27 can be written as 3 power 3 plus 3 square, because 3 into 3 and then here is 1, 3 square. Then this one get multiplied by this 3 only. So 3 plus 1. Suppose for k terms I will be getting 3 power k here. Then t n by 3 power k plus 3 power k minus 1 plus 3 power k minus 2 plus 1. So this is the sequence I will be getting after k steps. Now I have to go for the base condition. When n equals to 1, we are getting 1. So this is the base condition. Now I have to apply that. So how can I apply that? When this term will get 1, then it will be returning 1. So I will be comparing this term with 1. N by 3 power k must be become 1. Then only this sequence gets stopped, because that is the base condition. So now from this I can get n equals to 3 power k. Now applying logarithm both sides, because I have to find out what is the value of k. So log n equals to log 3 power k. This k can be written as k log 3, because this is in the exponent term, and according to the logarithm formula, this k can be multiplied before the log 3. So I have to find out what is the value of k. So the k will become log n by log 3. Okay, so if I will be taking the base value is 3, then this value becomes 1, and this is getting log n base 3. So what is the value of k? The value of k is log n base 3. So this will be getting 3 power log n base 3. Then this is t. This will become 1 plus 3 power log n base 3 minus 1. So replace what is the value of k in this equation. Okay, minus 2 plus 1. What is our job now? In this kind of equations, I have told you earlier, you have to take the most appropriate term. Okay, so these terms are lesser than this value, because if something is written like this 3 power k and something is written as 3 power k minus 1 plus 3 power k minus 2, then these terms are unnecessary, because asymptotically our order will be coming in terms of 3 power k. So this term is important, not these terms, because these terms are less than this term. So this is not that important. So we have to find out what is the value of this 3 power log n base 3. What is the value of this? You have to find out what is the value of 3 power log n base 3. So if you don't know what is the formula for this, so you can do one thing. Let's suppose I am taking n value is 3 power 10. This thing you can written as 3 power log n value is 3 power 10 I am taking, and the base is 3, and what I will be getting 3 power 10. The value of this can be written as, from this we can definitely written as 3 power 10. What is the value of n only? We are getting that value. I am taking n value as 3 power 10, and by solving this I am getting 3 power 10 as answer. So what should be the t of n? T of n should be order of n. So if you don't understand, look at here. We have to find the value of 3 power log n base 3. So the formula for this is order of n, because this 3 and this 3 will get cancelled according to the formula. If you don't know the formula, then do one thing. I am taking n value as 3 power 10. Anything you can take. Okay, so I will be getting 3 power log 3 power 10, because n value is 3 power 10 and the base is 3. What I will be getting 3 power log 3 power 10 base 3 is n only, and I am getting 3 power 10. So the n value only I am getting. Time complexity is order of n. Let's go for the third question. Okay, so this is the third question. Please pause the video and try to solve by yourself. So this is the base condition it is given. What is the job of ours? Just I need to write it like this. T of n equals to t of n minus 1 plus n. So I have to substitute this value now. What will be this value? If I will be putting n minus 1 in terms of n, then I will be getting t of n minus 2 plus n minus 1, because here n is there, that's why here n will added. Now here n minus 1 is there, that's why n minus 1 will get added. Now I will be putting this value value over here. So what I am getting n minus 2 plus n minus 1 plus n. Then the third value. If I will be replacing n minus 2 in terms of n, then how much I will be getting? N minus 3 plus n minus 2. I can replace it here. T of n minus 3 plus n minus 2 plus n minus 1 plus n. Suppose after k steps, what I will be getting? Seeing this sequence, you can guess that, right? So for k, I will be getting T of n minus k plus n minus k plus 1, then n minus k minus 2, then n minus k minus 3. In this sequence, we will be getting, lastly, we will be getting n here. Then coming to the base case. What are the steps you have to do? First step is write this equation, then substitute the value of this T of n minus 1 accordingly, and notice the pattern. Solve it, and for k steps, write the equation. Now we have to find out what is the value, what is the base condition. The base condition is for n equals to 0, it is returning 1. It will be stopping here. So to stop it, the k value should be T of n minus k should be 0, right? If n minus k should be 0, then k value should be n. So I am replacing here n minus n plus here I will be getting n minus 1 plus, in place of k only I am writing n here because that is the base condition. N minus 2, n minus 3. So this thing will be going on till plus n. Here T of 0 is 1. This is given here only. T of 0 is 1 plus n minus 1. I will be getting 1. Then n minus 2. I will be getting 2. Then 3. Then 4. This thing will be going on till n. For using substitution method, you have to remember some formulas. These formulas are very much important. One thing is, what is the addition of these terms? So if you will be adding n natural numbers, then the additions are, we should get n into n plus 1 by 2. If we will be adding n minus 1 term, then how much we should get? If n term we are adding, then we are getting n into n plus 1 by 2. That means we have to replace n by n minus 1 because we are adding n minus 1 terms. So here I will be replacing n by n minus 1, then I will be getting n minus 1 plus 1 by 2. The value should be n minus 1 into this plus 1 minus 1 get cancelled into n by 2. Okay, so this is simple only. Okay, so the third formula we can say that the addition of square of numbers till n. How much we should get? We should get n into n plus 1 into 2n plus 1 by 6. So this is the formula. You need to remember all these formulas. That will be useful in substitution method. The third thing is, if you will be adding the summation of the cube things, so 1 cube, 2 cube, 3 cube, 4 cube, this will be going on till n cube, then how much we will be getting? N into n plus 1 by 2 whole square. This is the term, we are getting the whole square of this. So this is one of the things, and some more formulas you have to remember. One thing is AP. You must know what is AP and GP. So for finding out a term in AP, for nth term if you want to find out, then the first term is a plus n minus 1 into d. This is the difference. Suppose what is AP? AP means if each consecutive term having some common difference. See here, 2, 5, then 8, 11, 14. So this term will be going on. Then see here, this is the difference is 3 here, 3 here, 3 here, 3. So this term is called D. Okay, so what is A? A is called the first term. N is called the nth term. What is the term you are going to find out? If I will be saying you what is the third term of this AP, what you should do? The first term is 2 plus n minus 1. N value is third term you want to find out. N minus 1 into D value is 3 because the common difference between each term is 3. So how much I will be getting? 2 plus 3 minus 1 is 2 into 3. So I will be getting 2 plus 2 into 3 is 6 plus 2. I will be getting 8. Or 8 is there. So these are some of the formulas you have to remember. Then one more formula in AP is sum of n terms. So I will be saying you sum 4 terms of this AP. So what should be the formula? N by 2 into 2a plus n minus 1 into d. So this should be the formula. So I will be saying you add these 4 terms. How much you will be getting? 2 plus 5, 7, 8, 15 plus 11, 26 we should get according to this formula. So n is 4 by 2, and the a value is 2 into 2 plus the n value is 4 because we want to find out what is the sum of the 4 consecutive terms. 4 minus 1 into d value is 3. Solve this. 4 by 2 is 2 into 2 into 2 is 4 plus 4 minus 1 is 3 plus 3. 4 minus 1 is 3 into 3. I will be getting 9. 4 plus 9 is 13 into 2 is 26. So this is the formula you have to remember. So one more formula can be derived from this, n by 2. If I will be writing this 2a as a plus a, it is possible, right? I can write 2a as a plus a. There should be no issue. So now see here, a plus n minus 1 into d. Have you seen this formula before? Yeah, we have seen this formula. A plus n minus 1 into d is called the nth term. So what should be this? This is the nth term. If you want to find out what is the sum of n numbers, then this is the first number and this is the last. First plus last into n by 2. This can be another formula. Then coming back to other things, GP. So what is GP? GP is same as AP, but here what happens? See one example, 2. Then I can write it as 6. Then 18. Then 54. This thing will be going on. See here, in AP the consecutive terms have same difference, but here in GP the consecutive terms would have same R value. What is R? R is the division value. If I will be dividing 6 by 2, then I am getting 3. Again, if I will be dividing 18 by 6, then I will be getting 3. Ratio of any two consecutive terms should be same. This is the property of GP. So how to find out a term in GP? If the nth term we want to find out, then what should you do? The formula is a into r to the power n minus 1. What is r? R is the ratio between two consecutive terms. For an example, if I will be saying find what is the fourth term in this GP. So what should you do? The first term is 2 into the value of r is 3 here, because the proportion of any two consecutive number in this GP is 3. So 3 into n minus 1. N minus 1 is 4 minus 1. So I am getting 2 into 3 power 3. 3 power 3 is 27 into 2 is 54. So this is the fourth term. First, second, third and fourth. Next, coming back to the next formula. So what should be the sum of n GP numbers? So suppose I will be adding these three terms. How much I will be getting? 18 plus 6, 24 plus 2, 26. So the sum of three numbers should be 26. The formula should be a into r to the power n minus 1 by r minus 1. This is the formula. So let's apply this. What is the value of a? A value is 2 into r value is 3. 3 power, the value of n is 3 here. So 3 minus 1 by 3 minus 1. The value of r is 3. 2 into 3 power 3 is 27 minus 1 by 3 minus 1 is 2. So 2 get cancelled. I am getting 26. So this is the value. If a GP is there and it is adding up to infinity number of terms, this is also possible. If it is adding infinity number of numbers, then what should be the formula for infinity number of sum of GP sequence? The formula should be a into 1 by r minus 1. Because the value of n is so high, this term will get cancelled out. Because the value of n is so high, then r power n minus 1 is tends to infinity. So we are appropriately making it a into 1 by r minus 1. This is the formula. These are some of the formulas you have to remember to solve the questions using substitution method. For this class, this much is enough, I think. From next class, I will be solving some more questions on substitution methods. So please be regular and share this video with your friends, and yeah, like the video, and please comment down below if you want to give any feedback. Thank you and have a nice day. All the best.